All right, y'all, and here's a video for the last problem in these notes, which is kind of going backwards from what we have been talking about. So this is the graph of the derivative, and our goal is to graph a possible function f of x. There are multiple options that we could draw because the derivative graph only tells us so much. But we can get the general shape of the original function. So that's what we're going to do. So the graph to the left is the graph of the derivative function, and we're going to graph f of x. All right, so what we're going to keep in mind is what it means when the derivative is positive, what it means when the derivative is negative, and what it means when the derivative crosses the x-axis. So I'm going to switch colors here and kind of highlight all of the points where our derivative graph touches the x-axis, because this means that at these 3 points, negative 2.5, 0, and 2.5, that means the slope of our original function is 0 at those points, which means that it's either a peak, a valley, or some interesting inflection point. And now, when our derivative is positive, so like on this interval, this means that our function is increasing. I'm just going to go ahead and write that. I'm just going to write INC, increasing, INCR. Okay, and now, from negative 2 up until 0 on this interval, we are decreasing. F of our original function, since our derivative is negative, that means our f of x is decreasing. And then we hit a slope of 0 again, and then we're still negative. So we're still decreasing. Our original function is still decreasing. And then we hit a slope of 0 again, and then our function switches back to increasing because our derivative switched to positive. Right now, let's go back to this first 0 right here at negative 2.5. Our function is increasing, then the slope is 0, and then our function is decreasing. So if you kind of think about it, we're going to be increasing, slope is 0, and then we decrease. So this is going to be like a peak or a maximum. I'll write a max, and then in parentheses, this will be a peak. Just writing down some information that will help us draw this. Okay, and then our function's decreasing, we hit a slope of 0, and then we're back to decreasing. So if you kind of think about this, this is not a peak nor a valley. This is something different. This will look something like this. We're decreasing, and then we hit a slope of 0, and then we continue decreasing. So this is what we call an inflection point. And we'll learn about this Wednesday this week. This point right here, an inflection point, is when our graph will switch from concave up to concave down, or vice versa. And the slope is 0 at that point. And that's what this point is. This will look something like this. And then finally, our last point where our slope is 0, we switch from decreasing to increasing. So if you think about it, we switch from decreasing to increasing. This will be a minimum or a valley. So I'll write min, valley. All right, now we have a lot of information here, and that'll help us all just draw our original function graph. So this is the graph of f of x. Let's see. So from negative 2.5 here, okay, I'll draw some little tick marks to help us out. Let's see. So at negative 2.5, we have a maximum. So I'll just draw our max point up here somewhere, because there's actually no way to know exactly where this is if we're going from our derivative graph to our original function. So this means our function is increasing up until this point, so I can draw something that looks like this. Because remember, this is from left to right, our function is increasing. And then we switch to decreasing. And then at 0, that's where we have that inflection point. So we'll decrease, 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 have a slope of 0 right here, and then continue decreasing. And then at 2.5, we switch. We have a minimum. Yes, at 2.5, which is close right here. 2.5, we switch from decreasing to increasing, creating a minimum. And this is a rough sketch of a possible function f of x given this derivative function f prime of x. So I'll just quick summarize. We know that at -2.5 we have to have a maximum because our derivative switches from positive to negative. Therefore, our function switches from increasing to decreasing. And then at 0, our slope is also 0. But our function goes from decreasing and then continues decreasing. So it'll be one of these points where we swap from concave up to concave down. And then at 2.5, when x is 2.5, our slope again is 0, and we switch from decreasing to increasing. Yes, so that's kind of how you would think about drawing a sketch of a function graph given a derivative graph. Just focus on when the slope is 0, when your function is increasing, and when your function is decreasing. So that's all. That's it for this video. That's it for the set of notes. Please email me if you have any questions or would like some extra example problems to work through this. We'll have a learning check for you this week and back to the book pages for this one. So email me if you have any questions at all over those assignments as well. And have a good week.